going to be a quick little video reviewing distance, rate, time problems, and the problem set that will be assigned with this particular video mixes all the problems up. So this is a mental checklist of steps that you should go through when you're reading a particular problem. The first thing you need to do is figure out which problem type you're reading. Is it an opposite direction? If so, this is your equation setup. Is it a round trip problem? If so, then this is your equation setup. Or is it a same direction, a catch-up problem? One car leaves early, one car leaves late, traveling at different rates. When does the fast car catch up with the slow car? That's your same direction scenario, and this is your equation setup. Once you determine which problem type it is you're dealing with, then you need to create your chart. Object 1, Object 2, one column is rate, one column is time. Fill in all the pieces that you can. Then the third step is to set up your equation. Using the information in your chart, you set up your equation, and the equation model gets set up based on the problem type that you're dealing with. And then the last step, as always, is to answer the question. So with this particular problem set, you need to get all of your information, but then you need to go back and read the question to make sure that you're actually answering the question. And then a few hints for this particular problem set. A few hints to help you with this. If you know the rate and the time, then it's easy to find the distance. You multiply those two things together. So for some of the problems, you're asked to find the rate or the time, and then the question may say, how far did they travel? Well, if you have both pieces of information, then you just simply multiply those together to get the distance. Second thing that you might need to understand, in a round trip problem, if the problem tells you that the entire trip, and I'm just going to use a hypothetical, I'm just going to say 10 hours. If the problem tells you that the entire trip was a 10-hour trip, and that's the only information that they provide, then the way that you would set this up with your time, you would say one leg of the trip, and I just sit here going, one leg of the trip would be the variable t, and then the return portion of the trip would be 10 minus t, or the total trip time minus the variable t. And of course you could flip those. This could be 10 minus t and this would be t. But the hint is if you're only given the entire trip time, then one leg of the trip is the variable and the second leg of the trip is the total time minus the variable. And then the other skill that you need to be comfortable with in order to do this problem set, you need to be able to determine how much time lapses between times given on the clock. So for instance, if one object leaves at 8 a.m. and arrives at noon, then you need to be able to figure out that that is a 4-hour time lapse. So you'll need to be able to, to do all of these skills. You'll need to be able to read and figure out what's being asked, and all three of these hints will help you with this problem set. So I've chosen the little puzzle problems, and the answers are given, so it's not necessary to find the answer, to find the riddle, but I like these because the answers are given for you. So on the first, I'm going to do problem number 4. And I've got my support work set up to go along with the scenarios that I just described, with the hints that I just described. So problem number 4, you have two jets traveling toward each other, and they are 3,400 kilometers apart. One jet is flying at 875 kilometers per hour, the other 825 kilometers per hour. In how many hours will the jets pass each other? And I don't think we had a problem like this in the other problem sets, so I've chosen to do this one with you on the video. So for starters, step number one is to determine which problem type it is that you're looking at. So with these, this is actually an opposite direction problem. The two jets are at opposite sides or opposite ends, and they're traveling toward each other. So the problem type here is opposite direction. And opposite direction is rate time plus rate time equaling total distance covered. And the way I have it sketched, they're starting at opposite sides, traveling toward each other. So the total distance traveled or covered would be, in this particular problem, they start 3,400 kilometers apart. So that's the total distance for this particular problem. And now reading the problem again, two jets traveling toward each other, One is traveling at a rate of 875 kilometers per hour. The other jet is traveling at a rate of 825 kilometers per hour. So I'm filling in the rate portion of my chart. I'm now moving to step number 2. And there's no mention of time. It just says in how many hours will the jets pass each other. So in how many hours will they pass each other? So that's just going to simply be the variable t. And now the third step is to set the equation up based on the type of problem you're dealing with and the information in the chart. So my equation for this particular problem looks like 875t plus 825t, and I set that equal to 3,400. So pulling all of my information together, needing to know the type of problem, the information in my chart. This is my equation setup. And now to solve this, this is 1700t. And therefore t is 2. And that means that t is 2 hours since the rate is given in kilometers per hour. And then to answer the question just simply says, in how many hours will the jets pass each other? So the answer to this question would be in 2 hours. And then moving to the other problem set, I am going to do, in the other problem set, I have chosen to do letter U. So I'm going to do letter U. And here I'll read it first, and then I'll go through all the steps and show you how to solve this one. A plane search. Our plane is on a search mission, flew east from an airport, turned, and flew back west to the airport. So this is a round trip problem. The plane cruised at 300 kilometers per hour when flying east, 400 kilometers per hour when flying west. The plane was in the air for 7 hours. So that's the key to the problem, in my opinion, as well. Both legs of the trip took 7 hours. How far from the airport did the plane travel? So let's walk through this together. So for starters, the first thing you need to do is figure out the problem type. So the jets started here and flew east and then turned around and flew back west. So this is simply a round trip problem. And the round trip setup is the rate time going equals the rate time returning. So it's just a round trip problem taking the same route, so the distance traveled on both legs of the trip is exactly the same. So now to go back and read the problem, I'm now in step number 2. I'm filling in the pieces in my chart, reading this again. Let's see, when the plane was flying east, it was traveling at 300 kilometers per hour, and when the plane was flying west, it was traveling at 400 kilometers per hour. Now, the plane was in the air for a total of 7 hours. So this goes back to the scenario that I was explaining here in the hints. When the only information you're given is the total trip time, the way that you would set your times up, here the entire trip time is 7 hours. So I would let one leg of the trip be t, and the other leg of the trip's time would be 7 minus t. Total travel hours minus the time it took to travel in one direction. And so I've got my chart filled in. I know my problem type. I'm now going to set up my equation, setting both equal to each other. Solve for the variable t. Let's see, I made a mistake, but that's okay. I can fix it. I'm making that a negative. I got ahead of myself. So now I have 700 t's, and t is 4. So t is 4. So if t is 4, that means that the eastbound trip was 4 hours, and the westbound trip would have been 3 hours. But when I go back and read the question asks me, how far from the airport did the plane travel? So this is where I need to use the first hint that I gave you. If you know both the rate and the time, the way you would find the distance is simply by multiplying those two things together. And since this is a round trip problem, when you multiply the first row together, you should get the same answer that you would get if you were to multiply the two the two numbers in the second row. So here, flying at a rate of 300 kilometers per hour for 4 hours will tell you that the plane or the jet traveled 1,200 kilometers from the airport. That would be the total distance traveled. And then you should check that 400 kilometers per hour for 3 hours would also result in 1,200 kilometers per hour. And I think that's enough information for you to do the other problems on your own.